Welcome to our lecture on remote access methods and security. By the end of this lesson, we will be able to summarize WAN and internet access types. We'll also be able to compare VPN topologies and protocols and explain remote host access and management methods, which are fundamental skills in any network profession. We discussed what a LAN versus a WAN is already, but WANs are designed to support data communications. And one of the technologies that could be used are some remote technologies for these WAN networks, right? Most WAN topologies operate across various layers of the USI model, and the physical layer defines the medium by which the interfaces are transmitting data. So that's the actual copper and the copper links, the fiber links. And we also have data link layers in the WAN technology, which pretty much is more simpler protocols than Ethernet in LANs, but it's increasingly used for more of an efficient end-to-end communication. At the network layer, we use the IP protocol, and we connect customers and provider sites via customer edge routers and provider edge routers. There are different internet types, right? And based on the speed and the accessibility, there's also the cost of implementation for these different technologies, right? So there you might have a T1 line, right? T1 lines are expensive. They're suitable for businesses that need a lot of uptime, and they offer different speeds, right? So the speed for T1 is reliable and a dedicated line. So there's high bandwidth, but it's less accessible, and because it's more expensive. A DSL is widely available. It uses existing phone lines with varying base distances from a provider. So a DSL line would probably be something like AT&T, and then we have cable internet lines which is broadly available in some urban areas. And it offers a competitive speed, but potentially affected by bandwidth. But it's still more cost-effective than a T1 line. Okay. As it relates to fiber, so there's also the fiber to the curb channel, fiber to the curb, or FTTC, which is consists of homes and businesses, but most of the connection is to the actual home itself. So it stops right at the home point, and it offers high speeds as it relates to compared to a copper line, but the speed that it provides it's limited to where it stops, to the curb, right? There is also fiber to the premise, which is pretty much the highest quality of internet access because you run fiber cables directly on your premises, but it offers superior speed, and it's pretty much it preps you for the future, right? It's an upcoming technology because if you have this, it improves your speed, but the cost of installation is higher, and there are also logistical challenges that may be involved with implementing that type of service, but it's still available to you. When we compare remote access methods, right, there are several methods for remote access, and one of them is a VPN. You could use VPNs for your remote access, where you could create a secure tunnel for data transmission over the internet. You could also reuse remote desktop protocols like RDP to allow for full potential control of a remote device. You could also use clientless VPNs, where you access network resources through a browser without having any specific dedicated software. And in order for us to have these remote access methods, we need to have remote access policies within our organization, where we only have authorized individuals connect to our systems. So these remote access methods include a bunch of different, several different policies, right? Where we have user authentication. You might have verification methods for whether it's two-factor authentication. You might have secure VPNs to encrypt the data and the transmission. We also should have endpoint security for our devices, so that's anti-malware, regular updates, and so on. And you might also have role-based access control. Some of the key tunneling protocols that could be used to facilitate the secure remote access is PPP, or the point-to-point protocol, which encapsulates IP packets over serial connections that lack inherent security. This one is not really that secure. There's GRE, which is the generic routing encapsulation for general purpose encapsulation at the network layer. There's also IP security, which is popular, that provides authentication and encryption at the network layer. You might see TLS and DTLS, which is the transport layer security, and datagram that offers secure communications over the session layer. There are other application-based protocols as well, but IP security provides, it's widely used, and there are two main IP security modes, right? There's the transport mode, which encrypts only the payload that is used within the private or on the private network, and then there's the tunnel mode, which encrypts the entire IP packet that is ideal for secure VPNs over a public network. In transport mode, as you look over here, everything, just the packet, the payload is encrypted, right, using that ESP over here. But there's also authentication that happens on the other end. The tunnel mode pretty much encrypts everything that goes in the tunnel, but not necessarily the actual traffic itself. Now, sometimes you might need IKE, or the Internet Key Exchange, to negotiate security associations, or SAs, for IP security. That would facilitate the actual mutual connection and managing some of the cryptographic keys that are essential for securing VPN connections. When we set up VPNs, there are certain setups that we could have. One of them is the client-to-site VPN or the site-to-site VPN. So we have two of them, right? So client-to-site VPNs are pretty much, they allow individual clients to connect to a corporate network over a public over a public network like the internet, right? That means one, like a computer to the actual site, like the computer to your main office. So people that work from home, they could actually connect for a VPN. Now there are two, in order to run this client VPN, you might see something called a split tunnel, which pretty much routes LAN traffic through the VPN, but the general browsing stuff does not really go through the VPN. With a full tunnel VPN, it's all of the traffic goes through the VPN. Right? It might be, whether it's personal information or not, all of the information goes to the VPN. But also see something called a clientless VPN, which pretty much allows access via a web browser. So that's a VPN that you could actually access. That pretty much is a cost-effective way to enhance your security by isolating your sessions within the browser itself. Now, the other type of VPN that we spoke about is a site-to-site VPN. That could be used, is a model that connects the entire network in a seamless way from one point to another point, right? So it's high security, simplified management, but it's also, you could think of this as a WAN connection, because it's ideal for mergers. If two companies if they are merging, you could connect these companies together. You want to connect an office, a site office, or even like a branch office to the main office, you could do that as well. For cloud integration, it's also really good to use site-to-site VPNs, because you could connect these companies' on-premise systems to their cloud service systems. For remote management, remote host access involves technologies like SSH and command line or an RDP, right? In most remote technologies, these methods help to control computers and other network devices. So like a switch, you could log into different switches using these different protocols over here. The first one, which is SSH, is a secure communication method to transfer files, for commands, to log into devices. So you could remotely log into a device using SSH, right? And all of our traffic is encrypted. The unsecure way of doing this, it would be Telnet. And Telnet is an older protocol for remote access that does not have the encryption that SSH offers, right? So the recommendation is to use SSH, which operates at port 22. RDP, which operates at port 3389, is more of a graphical user interface that could be used to log into devices remotely. The next one is console connections, right? So for console connection, we have we provide direct access to network devices for configuration and troubleshooting. OOB, which is the out-of-band management, it uses a dedicated channel for secure administration that ensures access even during network outages. what we might use to log into, like what we might use as a to access certain devices on a network is something called a jump box. And jump boxes serve as a secure entry point to manage servers and devices in secure zones that enhances the security by limiting access and simplifying the actual management of the network. And when we have our API connections, so facilitate automation and orchestration, normally we enable efficient and scalable configuration of network appliances to secure our authentication and secure our communication between our applications. This is critical. So if you know what an API is, which connects two applications together, and this is how the two applications communicate with each other, we want to make sure that we always secure these communications and these authentications, that the authentication between these applications throughout our network.